What's up, everyone? Today we're going to be converting quadratic functions from standard form to vertex form. But in this video we're going to be focusing on functions where the leading coefficient is either greater than 1 or less than -1. So if you want to see a video with simpler examples where the leading coefficient is just 1 or -1, I already have a video for that one. So this one's a bit of a step above. Alright, here we go. Alright guys, so here's the vertex form of a quadratic function, and the functions that we're given are in standard form, and so we need to convert standard form into vertex form so that we can readily see the vertex. And as we can see, the vertex is just going to be the opposite of our value in here, and then that's going to be the x-coordinate of the vertex, and then the y-coordinate of the vertex is just going to be whatever we see out here for k. So remember, in vertex form we have a binomial squared, and so to get a binomial squared we need to create a perfect square trinomial that we can factor. So here this is not a perfect square trinomial, so we need to make one, and to make one we complete the square. And so how we do that is I'm first going to ignore my constant term here. So I'm going to pretend like the plus 25 is not there. I'm just going to be dealing with my x terms here. And the first thing I'm going to do is I'm going to factor out the 6 here, because I'm trying to set myself up to complete the square. And so notice how the greatest common factor is actually 6x here. But I'm not going to factor out a 6x, I just want to factor out a 6 because I want my x terms to be intact when I go ahead and complete the square. So I'm just going to factor out a 6 because 6 goes into both of these terms. And so that's going to leave me with x squared minus 4x. And then I still have my plus 25 out here. Alright, so again, just to be clear, I factored out a 6 from these two terms, so I didn't factor one out from the constant term. All right, and now that we've done this, this is the part in here that we're trying to create into a perfect square trinomial. And so what I'm going to do is I'm going to complete the square for this in here. So I'm going to take this value, I'm going to take this value right here, the -4. I'm going to cut it in half, so that's -2. And then I'm going to square the -2, so I'm going to multiply the -2 by itself, and that's going to give me +4. And I'm going to add 4 to finish that trinomial there. And then I still have my plus 25 outside. And now I can't just add this for free, okay? Because I've adjusted. I haven't just rewritten this expression. I've actually changed it. I've added something, okay? And so I have to pay the price by removing the same amount. But this is very, very important. This is sort of what makes this trickier than when the leading coefficient is just 1. I haven't just added 4 here. So maybe at first glance you're thinking, okay, well I added 4, so I have to subtract 4 out here. But I haven't just added 4. The distributive property tells me that I've actually added 6 times 4. So I've actually added 24 to the expression. And so to make up for that, I have to minus 24. Okay? And now this, because we completed the square, we now have a perfect square trinomial that can factor. And so I can factor this trinomial into x minus 2, the quantity squared. And then I can combine my positive 25 and negative 24 into a plus 1. And now you can see we are in vertex form. So A is 6 in this case. But my vertex is just going to be the opposite of this value. So that's going to be positive 2. and k is the y coordinate of the vertex. That's just whatever I see right here. That's just going to be +1. Okay? So now, in this example here, we have a leading coefficient that's less than -1. All right, and so again, I'm going to ignore my constant term, and to set this up to complete the square, I'm going to factor out a -5, because -5 goes into -5x², and it also goes into the -30x. So I'm going to factor out my -5, and that's going to leave me with x². Now I have to flip this sign, because -5 times +6x gives me the -30x. Okay. And now I'm set up to complete the square for this binomial, turn it into a trinomial. And so I will cut the 6 in half. That gives me 3. I'll square the 3. That gives me a +9. So I'll add 9. And again, you might be thinking, okay, well, I added 9, so that means I have to subtract 9 over here. But you didn't just add 9. You've actually, turns out we've subtracted, because -5 times +9 is -45. And so we've actually subtracted 45 from the expression. So since I subtracted 45, I'm going to add 45 to make up for it. All right, now this is a perfect square trinomial that I can factor, and that's going to be x plus 3, the quantity squared, and then my -51 plus 45 is going to be -6. Oh, I forgot my y equals. All right, and now we are in the vertex form. So the x coordinate of my vertex is going to be the opposite of this. That's going to be -3. And the y coordinate of my vertex is going to be the -6. All right, and we'll bring this one to a close.